Hi, let us solve this other question on the relations between the coefficients of a quadratic equation and its roots. The question goes thus. The roots of the quadratic equation 2x squared minus x plus 6 equals 0 are alpha and beta. Find the quadratic equation with integral coefficients whose roots are alpha minus 2 beta and beta minus 2 alpha. How do we go about that? Let's start. Our quadratic equation is 2x squared minus x plus 6 is equal to 0. And we are told that the roots are alpha and beta. Now, if alpha and beta are the roots of this quadratic equation, we know the properties of the roots of any quadratic equation. The first thing, if we call the sum of roots as SR, then we are saying SR is alpha plus beta. Now there is a formula for that. It is minus B all over A. Now, if we look over there, we were supposed to first of all collect our coefficients. We know that our A is 2, our B is the coefficient of x, and our C is the constant term. So our A is 2, B is -1, C is 6. So for sum of roots, we will now put it as minus 1 all over 2. Negative multiplied to negative is positive, so we have our result is a half. All right, so we'll say alpha plus beta, which is sum of roots, is a half. Very, very capital information. That's our very first capital information that we have. Next, we look for product of roots. Product of roots, let us call it product of roots. Let us call it P subscript R. And so we're going to have P subscript R as alpha multiplied to beta. Now there is a relation for the product of roots. That relation is C all over A. What is our C? Our C is 6 and our A is 2. And so we're going to have 6 all over 2, which is 3. And so we're saying alpha beta is 3. This is what we get for product of roots. Fine. Now, we are given new roots. What are our new roots? The new roots given are, the new roots that were given are alpha minus 2 beta and beta minus 2 alpha to form a new quadratic equation. So we're going to use the symmetric properties of the roots of a quadratic equation to be able to come out with values for the product of new roots and the sum of the new roots. Let's start with the product of new roots. Let's call sum of the new roots, sorry. Let us call the sum of new root as S subscript NR. Sum of new roots, let's call it like that. Let's represent it as such. Sum of new roots. So it will be this root plus this root. To have alpha minus 2 beta plus beta minus 2 alpha. That is the sum. So if we open out this parenthesis, we'll have alpha, this alpha here, plus beta. We want to arrange everything in terms of the information that we have. We have alpha plus beta, we have alpha beta. So we can see alpha plus beta, then we're going to have negative minus 2 beta, this one minus 2 alpha. So we have alpha plus beta. Since there's negative common here, we'll factorize out the negative. Negative into 2 alpha plus beta. Okay. When we remove these negatives from here, we'll have 2 beta. This is 2 beta. And when we remove this negative from here, we'll have 2 alpha, positive 2 alpha. The negative is outside. Okay. So that's what we get at this level. Again, we should remember we want to make everything in terms of alpha plus beta and alpha beta, so that we can use these values, the values that we know. So let's keep this information again somewhere here. Alpha plus beta is a half. Alpha beta is 3. Let's keep this vital information there as we develop our solution. So we have alpha plus beta. Let's continue here. We have alpha plus beta. Now we have 2. Again, it's common. We'll bring out 2. So it will be this negative multiplied to 2 minus 2 into alpha plus beta. Okay. Now we have everything now in terms of alpha plus beta, alpha plus beta. We just go over there. We see our information. Alpha plus beta is a half. So this gives us a half minus 2 into a half. All right. These 2 cancels here. So we have a half minus 1, which is negative half. So sum of new roots is negative half. Very important information. Sum of new root is negative half. So let's get product of new roots. What is the product of new roots? Product of new roots. Let's call that P subscript N R. Okay. Product of new roots. P subscript N R. That simply means we take the new roots, we multiply out the new roots. Again, the new roots were alpha minus 2 beta. We're going to multiply out that with beta minus 2 alpha. We carry out that product. All right, so alpha multiplied to beta is alpha beta. Alpha multiplied to negative 2 alpha is negative 2 alpha squared. Negative 2 beta multiplied to beta is negative 2 beta squared. Negative 2 beta multiplied to negative 2 alpha. Negative multiplied by negative is positive. So we're going to have 2 multiplied to 2, 4. Then we'll have alpha beta. Again, we have to bring everything in terms of alpha plus beta and alpha beta. That's the work we need to do here. We should always remember. Bring everything in terms of alpha plus beta so that we can use that value a half, and alpha beta so that we can use the value 3. So we already have here alpha beta, so this is good. But here we have negative 2 into alpha squared minus 2 beta squared. Negative 2 is common. To have alpha beta, negative 2 is common, to factorize it out. When we remove negative 2 from here, we have alpha squared. When we remove negative 2 from here, we have positive beta squared. All right, so we should always check. Okay, if we open this parenthesis, do we get back this? Negative 2 multiplied by alpha squared, we get that. Negative 2 multiplied by positive beta squared, it gives us that. So this factorization is correct. Then plus 4 alpha beta. Okay, so you see alpha beta, there's 1 here. The coefficient here is 1. So 1 plus 4, 5. So we have 5 alpha beta minus 2 into alpha squared plus beta squared. All right. Alpha squared plus beta squared is not the same as alpha plus beta. So what are those symmetric properties? We know that alpha plus beta, all of this squared. Remember, this is not the same as alpha squared plus beta squared. We don't take the power out here and put on top of this and put on top of that. Okay, this is not the same as this. Okay, alpha plus beta all squared. All squared means alpha plus beta into alpha plus beta. All right, when we open up this parenthesis, alpha multiplied to alpha is alpha squared. Alpha multiplied to beta is alpha beta. Beta multiplied to alpha is the same alpha beta. Beta multiplied to beta is beta squared. Okay, so again, pay attention. We want to have everything in terms of alpha plus beta and alpha beta. Now, from here, what we need to do is to continue to arrange. We'll have alpha, beta, there are two of them. So we're going to have alpha squared, this one, plus beta squared plus alpha beta is 2 alpha beta. Okay, 2 alpha beta. Now, pay attention. We want to look for alpha squared plus beta squared. This alpha squared plus beta squared, look at it here. Okay, remember all of this is equal to alpha plus beta all squared. Alpha plus beta all squared. This left hand side, it is all of that. So, but we're interested in this. So what is alpha squared plus beta squared? What is that? This should be equal to, we take this one from the left hand side that way. So we're going to have alpha plus beta all squared minus 2 alpha beta. So alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. So in the place of this expression here, we're going to put all of this. Again, our aim is to have alpha plus beta, alpha beta. Look at it, alpha plus beta and then alpha beta. So we just come here now, in the place of this, we write this expression. So our product of new roots now becomes, we still continue, is 5 alpha beta minus 2 instead of alpha squared plus beta squared, we write all of that, minus 2 into alpha plus beta squared, alpha plus beta squared minus 2 alpha beta, minus 2 alpha beta. Okay, so this gives us, we open this parenthesis, 5 alpha beta. All right, negative 2 multiplied to all of that is negative 2 alpha plus beta squared, all squared. Negative 2 multiplied to negative 2 gives us positive 4 alpha beta. All right, this is 4 alpha beta, 5 alpha beta, so we add them up since they are like terms. It's going to give us 4 plus 5 is 9. 9 alpha beta minus 2 into alpha plus beta all squared. So this is the expression of the product of new roots in terms of alpha plus beta and alpha beta. So we'll just come and put now our values. This will give us 9 into alpha beta is 3 minus 2 into alpha plus beta is a half, but a half having squared. So we'll put a square there. All right. So we now get 9 multiplied to 3 is 27 minus 2 into a half squared is 1/4. So we have 27 minus 2 multiplied to 1/4, 2 here 1, 2 there 2, so it's minus a half. This can also be written as a fraction, and then we'll carry out the subtraction. LCM is 2. 2 divided by 1 is 2 multiplied by 27 is 54. All right, 2 divided by 2 is 1 multiplied to 1 is 1. So this gives us 53 all over 2. All right, so This is the product of the new root. The product of new root gives us 53 all over 2. All right, so we're about concluding our work. Let's recollect the information that we know so far. We know sum of new roots. We found it to be negative half. Now, product of new roots. We found it to be 53 all over 2. So, how do we get the required quadratic equation? Okay, the required quadratic equation has the nature x squared, because our variable is x squared minus sum of new roots multiplied to x plus product of new roots equals 0. This is the nature of the quadratic equation. So let's put in our information. So we're going to have x squared minus sum of new root is negative half. So we have negative half multiplied to x plus product of new roots. We have 53 all over 2 is equal to 0. Now, making it look nice, all we need now do, since we have a common denominator 2 here, we multiply all through by 2. So if we multiply all through by 2, we're going to have 2 into x squared minus gives us positive. So this one becomes positive half x plus 53 all over 2 is equal to 0. So we're multiplying all through by 2. 2 multiplied to x squared gives us 2x squared. 2 multiplied to a half, this 2 will cancel. We have positive x. 2 multiplied to 53 all over 2, this 2 will cancel that 2 there, and we'll end up with 53 equals 0. All right, so this is the new quadratic equation. The new quadratic equation formed from the information we know about this given quadratic equation. This given quadratic equation has the roots alpha and beta, and we're told that this one has roots alpha minus 2 beta and beta minus 2 alpha. Okay, thank you.